Okay, Ms. Howard's Chemistry Unit 12. This is Section 6, PowerPoint number 6 for acids, bases, and salts. And we're going to focus on the text where we define pH and use the hydrogen or hydroxide ion concentration to calculate the pH of the solution. All right, pH, capital letter D on your notes, stands for the negative log of the hydrogen ion concentration. We'll go over this in massive detail in class. All you need to do is use your calculator, and it's got all the spiffy buttons for us. So you've got these hydrogen ions in water. Pure water ionizes or falls apart into ions. Remember, we talked about in the last section, H plus and OH minus. It does do that a little bit on its own, but not very much. But they call this the self-ionization of water. And it occurs to a very tiny extent. How much? At any one point, you're going to have, see that number down there? 1 times 10 to the negative 7 moles of the hydrogen ions in water. That means like 0.000001 moles of water molecules are pulled apart into ions. Basically, that means it's a tiny stinking little amount. And so much so little that when you take pure water, that deionized water, and you put our little electrode conductivity testers in there, it doesn't light up any of the lights at all. You guys did this in your lab. The distilled water didn't light up the light. So it occurs in a very small extent. However, they use that as the comparison, the standard. They're saying, okay, since the H ions and the OH negative ions are equal, they say that's a neutral solution. So that distilled water, that's where we get our pH of 7. Okay, all acids produce the hydrogen ion when placed in water, or hydronium, we talked about that. And all bases produce the hydroxide ion when placed in water. If something has a pH of 3, it means that the H plus ion concentration is 1 times 10 to the negative 3. So you see that little 3 superscript? That's where they got the pH. If you take negative log, hit on your calculator, negative log 1 second EE negative 3, then it's going to give you the answer of 3, which, why would you do all that when all you have to just say, oh, look, it's 3? And this guy named Sorensen, I guess he was really tired of writing out that 1 times 10 to the negative 3 or 1 times 10 to the negative 14 or blah, blah, blah. He said, let's just make it easier and let's just use those superscripts, and how you get that mathematically is negative log of the hydrogen ion concentration. So thank you, Sorensen, for giving us the pH scale. So here is a lovely graphic of the pH scale. It measures acidity and basicity. Yes, that's a word. Acids are on the left, 0 to 7. Bases are on the right, 7 to 14. And neutral is right at that 7 mark. Each step, this is huge, each step on the pH scale represents a factor of 10. So if you have a pH of 1 and a pH of 2, that means the pH of 1 has 10 times more hydrogen ions in it than the pH of 2 does. So it's 10 times more acidic than the pH 2. And pH 3 is 10 times less acidic than pH 2. Yes? Right. So if you have pH 5 versus pH 6, it is 10 times more acidic. If you have pH 3 versus pH 5, it's 100 times, because you've got 2 loops there. 2 lines, 2 jumps. And, well, let's go on. If you have pH 8 versus pH 13, how many different jumps did you go through? Oh, I have to go back on that one. Let's see if it'll let me. No. I don't know why it's not going to let me go back. Oh, there it is. Let's go back anyway. There we go. So you have the pH 8 versus pH 13. So we have 1, 10, 100, 1,000, 10,000, 100,000. So you end up with a pH that's 100,000 times more acidic. 8 has a pH that's 100,000 times more acidic than the pH of 13. Even though they're on the base side, we're measuring it measuring the H ion concentration, which is the acid. Okay, so again, here we have the pH scale. All the way up at 0, you've got the acids, and all the way down to the bottom, you've got the bases. And you see that word over on the left at the bottom, alkalinity, alkaline. Remember on the periodic table we had the alkaline earth metals? The reason they refer to them as alkaline earth metals is because when you put them in water, they form bases, or they're alkaline. Okay, we can measure pH with a lot of different tools. The easiest stuff we use is the litmus paper or the pH paper. So what good is it? Everything from swimming pools to soil conditions for plants and medical diagnosis, they test the pH. Soaps, shampoos, you'll even listen to commercials that'll say, "Ooh, the deodorant is pH balanced for a woman." Sometimes you can use indicators. Other times we need a pH meter, and they look at a lot of different things. Indicators are kind of cool because they change colors at different pHs. So if you put this indicator in the liquid and then you add an acid to it or you add a base to it, then you can get it to change all sorts of weird colors. So indicators are compounds whose colors are sensitive to pH, and they change color according to the pH. Those are called redox reactions. When they change colors like that, they're usually talking about swapping electrons around, and they have an oxidation and reduction characteristic to them. Some of the many pH indicators, we have like a list of 50 of them. We have quite a few back in the back room. They're very pretty. Measuring pH with wide range paper. This is what we have, and we like to use this a lot. Moisten the indicator strip with a few drops of solution by using a stirring rod. Like if you put the opposite end of your rubber police in the glass stirring rod and dip it in there and put a drop of it onto the pH paper. Notice the entire piece of the pH paper is not wet. You need some of the original color left on there. It makes it easier to tell or to figure out what color it is changing to. And you just look on the container and you can see what pH is it according to the color. It's not perfect. Usually the best thing is to use several different ways to determine the pH, and then that way you get a good idea of what the pH is. So here are the little scale on the side of the pH container. So you compare the color to the chart on the vial and you read the pH value. It's very simple. There are lots of little different tools that you can use to do the pH. Some of the tools we have are kind of sensitive and they require a lot of care. Some of the probes that we have that go with the AP chemistry, I need to fix some of them. Ooh, we have a fade out.